Okay, in this lecture we're going to talk about inequalities. So far we've been talking about equalities, which is a much more powerful condition because we're requiring things to be equal to each other. For example, for an inequality, this opens things up considerably because if you think of a number line and we're looking at, say, here's our number 3, and we're looking for all the x values that are equal to 3, then we only have this one, okay? But if I'm looking for x values which are greater than 3, then we're including everything that is to the right of 3. So we have an infinite number of solutions, as you can see here. So an inequality will produce many, many more solutions than an equality. Right, so a couple of things to keep in mind here. First of all, some properties that we need to keep in mind when it comes to inequalities. Right, so if I have A, B and C are real numbers, right, and number one, if I have that a certain number, A, is less than B, all right, then if I add C to both sides, it doesn't change the inequality. Okay. Similarly, if I had A was greater than B, then the same thing would happen. A plus C would be greater than B plus C. Okay. All right. So also this works for multiplication. If I have, again, A is less than B, then if I multiply, and in this case, if C is greater than 0, so it's a positive number, then AC will also be less than BC. Similarly, if A is greater than B, then if we have C as a positive number, then AC will be greater than BC. Alright, so the thing that changes here is this. Alright, you can see this up here working because we know that, say, 2 is less than 5, then 2 plus 3 is certainly less than 5 plus 3. Alright, so 5 is certainly less than 8. So it works fine there. Same as for multiplication, if I have 2 is less than 5, then 2 times 3 is less than 5 times 3. In other words, 6 is less than 15. Right, now where things change is what if I did a negative 3? Then I'd have negative 6 is less than or equal to negative 15, which of course is not true. Alright, so we need to make sure that we have that particular case, and that is if A is less than B, and in this case, if C is less than 0, a negative number, all right, then AC is going to be greater than BC. Notice that we flip the inequality when we're multiplying and therefore when we're dividing by a negative number. All right, now all these will also work if I have less than or equal to or greater than or equal to. The same thing will in fact occur. Now when we talk about a linear inequality, then we go back to what we remember about a linear equation. A linear equation, of course, was AX plus B was equal to 0. That's the equation. For an inequality, we would have that AX plus B, all right, would be, say, greater than 0, or we could have AX plus B would be less than 0, or we could have AX plus B is greater than or equal to 0, or we could have AX plus B is less than or equal to 0. So these are the different kinds of scenarios here where A, B and C, all right, are real numbers, and of course A can't be equal to 0 or we wouldn't have a linear form like AX plus B. Right, now to solve an inequality like this, we apply the properties. So let's do an example. All right, let's suppose I want to solve negative 2x plus 7 is less than negative 5. Okay, now we do exactly the same thing. We think about this as being a equal signs as long as we're not going to multiply by a negative number or divide by a negative number, same thing, multiplication and division are the same thing. What we want to do is isolate the x. So the first thing we do is we subtract 7 from both sides. Okay, so now I have 2x is less than negative 12. Okay, right, now don't go just dividing now by negative 2, because remember, when we're dividing it's the same as multiplying, and we're dividing by a negative number, so we're going to have to switch this around. Alright, so what we're going to need to do is say, well, this is going to mean that negative 2x, when I divide it by negative 2, is going to be greater than negative 12 divided by negative 2. Okay, which implies that x is going to be greater than 6. Now the way we write this is in set form. This would be the set x such that x is greater than 6. Okay, this is what's called set builder notation. Alright, for the solution. For interval notation, then x is greater than 6 would mean we would have everything more than 6, so not including 6, so we use a curved parentheses all the way up to infinity. Okay, there's always a curved parentheses on infinity, whether it's positive or negative infinity. Alright, and if so this is interval notation. Okay, and another way we could do it is use a number line. So let's suppose here's 0, and let's suppose here's 6. Then we'd use a curved bracket, and it would be this set here. So this is a graph of it, if you like. Alright, so there are the 3 different ways we can actually do the solution. Now it's very important that you understand the different ways to write the solutions. And so on page 147 of the text, alright, make sure you are clear, alright, so be clear on the different solution forms. Okay, there's a big table there to make sure that you know how to do that. Alrighty, so that's how we do linear inequalities. Okay, perhaps we'll just do one small example again. So let's call that example 1, and here's example 2. Right, let's suppose I want to solve 3 minus 4x, right, is greater than or equal to 2x plus 8. So let me see if I can fit this in, so watch it carefully. Alright, so the first thing we should do here, of course, is isolate the x's on the left side. So I'm going to subtract 3, alright, from both sides. Okay, so I'm going to end up with negative 4x is greater than or equal to 2x plus 5. Okay. Right, now we're going to subtract 2x from both sides. So I'm going to get negative 6x is going to be greater than or equal to 5. Right, notice we're going to have to divide through by negative 6. So negative 6x divided by negative 6. Now we flip the inequality because it's a negative we're dividing by. And we'll have 5 over negative 6 here. So in other words, we'll have x is going to be less than or equal to negative 5, 6. Okay. All right, now it's equal to, so there's a couple of ways of doing the solution here. It would be x such that x is less than or equal to negative 5, 6. In interval notation, it would be from negative infinity to negative 5, 6, but including it, so we use a square parentheses like so. So that's that form. And if we want to do a graph of this, let's suppose here's 0, then negative 5 on 6 here, and it would be this direction. And that would be our solution for this kind of problem.